Let's take a look at our first test section, section 1.1, linear equations and rational equations. And specifically, we'll start off with the first topic, the linear equations. And we won't do every one of these topics. We don't have time, so I'll kind of jump around a little bit. Solving linear equations. We have a note that goes up top. It says at any step, combine like terms and combine numbers. And our first step says to get rid of parentheses. We do this via the distributive property. Second step says get rid of fractions. And we multiply by the LCM of all the denominators. Step 3, get everything with an X on one side, numbers on the other side. Step 4, divide both sides by the number in front of the X. Now I'm writing this in terms of X, but you can have any variable. Step 3, get everything with an X on one side. I'm talking about terms. So get all of your variable terms on one side and your constant terms on the other side. And then step 4, divide both sides by number in front of the X. Number in front of X is called a coefficient. I tend to leave off the math terms, the definitions, when I'm writing this step by step, just so you're not caught up on the definition and not understand the steps of them. Okay. Let's say I have 7 times x minus 2 plus 3x is equal to negative 2 times x minus 1. Now I'm going to be going through my steps here. First step is get rid of parentheses. Then it says do that via the distributive property. So we'll take the 7 here, multiply it times the x, and times the negative 2. Then I'll take the negative 2 and multiply it times the x and times the negative 1. 7 times x is 7x. 7 times negative 2 is negative 14. And then the 3x carries down. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2 times negative 1 is positive 2. Now our note up at top said at any step combine together like terms. Here we got 7x plus 3x. That gives us 10x. Minus 14 is equal to negative 2x plus 2. Now oops, I should have wrote that down. Step 2 says get rid of fractions. We don't have any fractions. Step 3, get everything with an x on one side, numbers on the other side. So I'm going to take this negative 2x and move it to the left side. And I'll take this negative 14 and move it to the right side. Anytime you move anything across or equals, your sign changes. So the negative 2x becomes a positive 2x. The negative 14 becomes a positive 14. Now our note up at top says in any step combine together like terms. 10x plus 2x is 12x. And combine together numbers. 2 plus 14 is 16. Then, on step 4, divide both sides by a number in front of your x. The number in front of x is 12, so we'll divide both sides by 12. And these 12s cancel. Then we've got x is equal to 16 over 12. These are both divisible by 4, so that gives us 4/3. 16 divided by 4 is 4. 12 divided by 4 is 3. And that's our answer. Now, let's say I have a problem. It looks like this. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. Now I got three denominators, 4, 3, and 12, and my LCM would be 12. So I'm going to take 12 times x over 4. Now when we're figuring out what to multiply 12 by, it's whatever's separated by pluses, minuses, and equals. So here's a plus, so then I'm going to multiply the 12 times 1/3. Here's an equals, so then I multiply the 12 times negative 7x. And here's a plus, so I multiply the 12 times 1/2. Now 4 and 12 both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 and 12 both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And 2 and 12 both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Notice how all of our denominators have disappeared. So we're left with 3 times x, which is 3x, plus 4 times 1, which is 4. 12 times negative 7, which is negative 84x. And then 6 times 1, which is 6. Now let me double check that real quick. Okay, yeah. Step 3. Get everything with x on one side, numbers on the other. So I take the negative 84x over the left side, and I take the 4 over to the right side. Remember, when you take anything across your equals, your sign changes. The negative 84x becomes a positive 84x. And the positive 4 becomes a negative 4. 3x plus 84x is 87x. 6 minus 4 is 2. Combine together like terms, combine together numbers. And step 4. Divide both sides by number in front of your x. Number in front of your x is 87, so we'll divide both sides by 87. And we get x is equal to 2 over 87. Those 87s cancel. Now you notice we come up with a fairly nasty answer. It doesn't come up like x equals 1 or x equals 2. That oftentimes occurs whenever I make up a problem. Whenever I make up a problem, then you see fractions like that. Let me clear that off. And our next topic is talking about conditional equations, identity, and contradictions. That's a type of equation you're working with. And if you're working a problem down and you come up with an answer, those indicate steps you can't see. So I come up with x equals 3. Of these 3 types, this is a conditional equation. Conditional means you found an answer. X is equal to 3. It means that my original equation is conditionally true whenever x is equal to 3. Now if I'm working a problem down and I'm solving it, and all of a sudden the x disappears. I no longer have the variable. And I come up with like a number equal to a number. In this case, 2 is equal to 3. Well, you have to ask yourself, when is 2 equal to 3? And it's never equal to each other. This, in mathematics, would mean no solution. There's no answer to the original equation. Now, in terms of what they're looking for here, though, see how they say contradictions? This would be called a contradiction. Different books have different names for that. And if I'm working a problem down and all of a sudden my x disappears again, and I come up with something that is always true, like 5 is equal to 5, 2 is equal to 2, 0 is equal to 0. This is our last case. This is an identity. But when we're saying identity, there's still an answer. There's actually an infinite number of answers. Means no matter what I plug into the original problem, it'll work. So that's a little bit different than our conditional, which came up with one answer. Okay, next topic we're going to take a look at is solving rational equations. Okay, so solving rational equations. Step 1, get rid of parentheses. You very rarely ever have parentheses in these rational equations, but we would do it via the distributive property. Now step 2, get rid of fractions. And we in order to get rid of fractions when talking about rational equations, let me go ahead and write out the steps for that. Typically, we factor all our denominators. Figure out the LCM of all the denominators and multiply everything by it. Then step 3, you solve for x, and that's pretty vague. That's what we're doing initially. But it'll either be a linear equation at this point, which then you use the 4-step method we just looked at for solving linear equations, or it'll be a quadratic equation. Quadratic means you have an x squared, and we would use the zero factor property for this. And then step 4, excuse me, semi-check your answers. And we'll talk more about that when we look at our first example. Let's see. I can't make these up out of my head, so I'm going to show some of them here. Or show one of them. I really don't have time for much beyond that. But let's take a look at this one here. We got 8 over x plus 4 minus 2 over x minus 3 is equal to negative 5 over x squared plus x minus 12. And what makes this a rational equation? Rational equation means you got an equation which has got an equals in it, and the rational part means you got a variable x, for example, in the denominator of some form. It's pretty vague, but it really is that vague. Step 1, get rid of parentheses. Don't have any parentheses. Step 2, get rid of fractions. And first thing we do there is factor all the denominators. Now x plus 4 we can't do anything with, x minus 3 we can't do anything with, but x squared plus x minus 12 is the PSD method. And this becomes 8 over x plus 4 minus 2 over x minus 3 is equal to negative 5 over x plus 4 times x minus 3. B, figure out the LCM of all the denominators and multiply everything by it. Now that we got the denominators factored, let's take a look at each factor. I'll start with the x plus 4. Now I'm looking for the greatest number of x plus 4s in a single denominator. There's one here, none here, one here. So the greatest number of x plus 4s in a single denominator is 1. Then I go to my next factor, the x minus 3, and I'm looking for the greatest number of x minus 3s in a single denominator. There's none here, one here, one here, so the greatest number of x minus 3s in a single denominator is 1. You notice we're not counting how many there are. We're looking for the greatest number in any single denominator. So this is our LCM. And then it says multiply everything by it. So we're going to multiply our first fraction by it, the 8 over x plus 4. We're going to multiply our second fraction by it, and I'll put it after it just so I don't lose track of this negative that's out in front. And we'll multiply times the fraction on the right side. Well, this x plus 4 cancels this x plus 4. This x minus 3 cancels that x minus 3. This x plus 4 cancels that x plus 4, and this x minus 3 cancels with this x minus 3. So we're left with 8 times x minus 3 minus 2 times x plus 4 equals negative 5. So then 8 times x is 8x. 8 times negative 3 is negative 24. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. 8x minus 2x is 6x. Negative 24, negative 8 is negative 32. Step 3, solve for x. This is a linear equation. The reason why it's a linear equation is because we've got x to the first power. So we'll go through our steps for solving a linear equation. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with x on one side, numbers on the other. So I'll take negative 32 over. Then we got 6x is equal to negative 5 plus 32. Negative 5 plus 32 is 27. Then our last step for solving a linear equation is to divide both sides by the number in front of your x, which is 6. And 27 and 6 are both divisible by 3. That gives me 9/2. Now step 4 says semi-check your answer. What that means is plug that back in the original equation and make sure it does not cause any denominator to equal 0. For example, if I put 9/2 here, 9/2 plus 4, I don't know what it is, but it's not 0. That's all I care about. 9/2 minus 3, that's not 0. 9/2 squared is 81 over 4 plus 9 over 2 minus 12. And I don't know what that is, but it's not 0. So that's what we mean by semi-checking it. You don't have to fully check it, you just got to semi-check. Okay, let me clear that off. And let's take a look at solving literal equations for a specified variable. Literal equation, another name for that is formula. So I'm going to say solving formulas for a variable. Our first step is to get rid of parentheses. Now we do it in the same manner. We use the distributive property. Step 2 is get rid of fractions. And we do that in the same manner. We multiply everything by the LCM of all our denominators. Step 3, get everything with the variable we are solving for on one side, everything else on the other side. Step 4, if the variable you're solving for is in 2 or more terms, then factor it out. Now technically they do not have to be terms. They will be for this course, but if you go on, you could have items that have trig expressions or radical expressions in them that are not terms that just still applies. So if you just have 2 or more of that variable, then you do it. And step 5. Divide both sides by what is in front of / back of the variable we are solving for. So for example, I might have some examples up here actually. Some of these I can make up fairly well, some not at all. This one actually might show up pretty good, but let me show this one first. I got A is equal to B over x plus y. And I want to solve that for x. Okay, so we're going to go through our steps. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. So we're going to multiply everything by the LCM of all our denominators. Now we only have one denominator, so that is our LCM. So we're going to take A times x plus y, and we'll take x plus y times a fraction, times the B over x plus y. A times x is ax, a times y is ay. Over on this side, the x plus y's cancel, and we end up with b. Now step 3, get everything with the variable we're solving for on one side, everything else on the other side. We're talking about terms for this course, but they don't have to be terms. Now we're solving for x, so we want to get everything with x on one side and everything else over on the other side. So I'll take this ay and move it over. So we got ax is equal to b minus ay. Now our fourth step says that the variable you're solving for is in 2 or more terms and factored out. It's only in one term here. Step 5. Divide both sides by what is in front of / back of the variable we're solving for. We're solving for x and there's an a in front of it, so I'll divide both sides by a. Do that, those a's cancel, and we got x is equal to b minus ay over a. And that's our answer. Grab a drink here, then we'll look at the next topic. I'm going to skip over these applications. I really don't have time to go into those. But if they're already in the ebook that you want to see work, just email me. Say, hey, work these 5 and I'll work them and send them back to you. Okay, complex numbers. Now we have something called standard form for complex numbers, and that's when it's in the form of a plus bi, where a and b are numbers. Now they can be any type of numbers. They can even be zeros. So that's standard form. No matter what, we always want to put it in standard form when we're working the problem. Now our definition of I. I comes about if you end up with a square root of -1. It's actually a little bit more than that. Whenever you have a radical with an even index and you got a negative number inside, then you end up with an I. But square root of -1 is equal to I. So if I had a problem that asked me to simplify the square root of -25. Well, -25 is -1 times 5 times 5. Remember, with square roots, we're looking for a pair of somethings. Here's a pair of 5, so a pair of 5 is going to come out in front. And whenever you have a -1 inside your square root, that comes out as an I. So that'll give us 5i. And since there's nothing left inside the square root disappears completely. Now if I had this problem, I want to simplify the square root of -12. That's -1 times 2 times 2 times 3. Again, we're looking for a pair of somethings. Here's a pair of 2s, so they're going to come out in front as a single 2. And here's a -1, now come out as an I. So that gives us 2i square root of 3. And that would be our answer. Now when you're working with i's, you really want to treat them pretty much like variables. We'll talk about, in some cases, you have to rewrite it in the standard form and how we handle that. But let's take a look at adding 2 complex numbers. Now here, I got 2 sets of parentheses, and these parentheses really aren't doing anything, so I can drop them. So I got 3 plus 5i plus 3 minus 5i. The I is our imaginary part. If I think of them as variables, though, we would just combine together like items. For example, 3 plus 3 is 6, and 5i minus 5i drops away. So I'd give us 6. So again, if this is 5x minus 5x, drops away. Same idea with the i's. Now if I have 7 minus 2i minus 3 plus 8i, for subtraction, we again want to get rid of parentheses, and this first set of parentheses isn't doing anything, so I can drop it. So I got 7 minus 2i. Remember, if you have a negative in front of your parentheses, flip the sign of everything inside. So I still flip the sign of the 3 and of the 8i. So positive 3 becomes a negative 3. The positive 8i becomes a negative 8i. Now combine numbers. 7 minus 3 is 4. And then we got negative 2i, negative 8i, which gives us a negative 10i. And that would be our answer. Now we have another definition that comes up fairly often when we're talking about imaginary numbers. And that's what I squared is equal to. I squared is equal to negative 1. And I won't go into the proof here, but if you go back to the previous definition of I and square both sides, you get that. Now that comes in handy when we're working with multiplication. So if I have 3 plus 2i times 5 minus I, and I'm multiplying these together, we would FOIL. So you take 3 times 5, multiply your first parts together, plus 3 times negative I, our outer parts, 3 and the negative I, plus 2i times 5, the inner parts, plus 2i times negative I, the last parts. 3 times 5 is 15. 3 times negative I is negative 3i. 2i times 5 is 10i. And 2 times negative 1 is negative 2, and I times I is I squared. Now we always want to combine together like items. Negative 3i plus 10i is 7i. And we don't want an I squared. That's not standard form. But remember, we just said that I squared is equal to negative 1. So I can replace the I squared in this problem with a negative 1. So that gives us 15 plus 7i. Negative 2 times negative 1 is positive 2. 15 plus 2 is 17. So we end up with 17 plus 7i. Now if I talk about division, if I have a single I down in denominator, like this problem, 5 over I. Now you might have a number with it. You might have like, let me go ahead and put it here. You might have a 2 in front of it. But the gist of it is you have a single I down there and you don't have 2 items. You just have 2i, 3i, negative 5i, something like that. This is referred to as division, but we really don't actually divide. We're trying to get rid of the I down in the denominator. And how we do that is we multiply the top and bottom by I. And you always do that whenever you have a single one down here. Now 5 times I is 5i. 2, and then I times I is I squared. But remember, I said we don't want an I squared. And up above we said I squared is equal to negative 1, so I can replace the I squared with negative 1. So that gives us 5i over negative 2, or if I were to put it in the form, this would be negative 5/2 I. Now if you compare that to a problem where you have 2 items in your denominator, a real part and an imaginary part. Now our goal is still to get rid of the I down there. In this case, what we do is we multiply top and bottom by the conjugate of the bottom. So the conjugate is 2 minus I. Now what makes a conjugate is the first part's the same, 2 and 2. The last part's the same, I and I. But the sign in the middle is different. This is a positive, this is a negative. Now up on top, we're going to take 7 times 2 minus I. Now on the bottom, the nice part about conjugates is all you have to do is multiply your first parts together and your last parts. So I'm going to have 2 times 2 plus I times negative I. So 7 times 2 is 14. 7 times negative I is negative 7I. 2 times 2 is 4. A positive times a negative is negative, and I times I is I squared. So that gives us 14 minus 7I, and then 4 minus, and remember we replace I squared with negative 1. So that gives us 14 minus 7I over 4, and then negative negative becomes a positive. So that gives us 14 minus 7I over 5. Now you split this up. Real part separate from the imaginary part. So you put 14 over 5 minus 7 over 5 with an I to the side. And that would be your answer. Now we got powers of I. I to the first power is I. I squared we said was negative 1. I to the third is equal to negative I. And I to the fourth is equal to positive 1. And then it repeats. So I to the fifth is I to the sixth is negative 1. I to the seventh is negative I. And I to the eighth is a positive 1. So it repeats in groups of 4. Now this comes in handy if you have something like I to the 201st power. Obviously I don't want to build this table out to 201 power. So what we do instead is you divide by 4. And it's always by 4, and if you're wondering why 4, it repeats in groups of 4. That's why we divide by 4. Now 4 goes in 25 times. 5 times 4 is 20. Subtract that, and I end up with a 1 here. 4 does not go into 1, so that'd be a 0. 0 times 4 is 0. Subtract those, and this would be my remainder. So I rewrite this as I to the first power. When you divide by 4, whatever your remainder is what goes in the denominator, in the exponent. And then the I to the first power is simply just I. So that would be what I to the 201st power is equal to. Okay, let me clear that off. Grab a drink, and then we'll take a look at the next topic. Okay, quadratic equations, 1.4. Let's first take a look at the zero product property. And zero product property says if you got, and I referred to this earlier as a zero factor property, but same idea. If you got something times something is equal to 0, and that's pretty vague, then you set each factor equal to 0. But it really is as vague as what I just said. As long as you have 0 on one side and the other side's written as a product, no matter what it is, you can set each of the factors equal to 0. For example, if I have x squared minus 9x plus 14 equals 0. And I'm wanting to solve this using the zero product property. First off, you have to have 0 on one side. If you don't have 0 on one side, you have to work to getting 0 by itself. Then we want to factor the other side. Well, this factor is using PSD. So this factors as x minus 2 times x minus 7. And then our zero factor property. If you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0, and I'll set x minus 7 equal to 0. And then if you solve those, you get 2 and you get 7. And those would be your answers. let's take a look at the square root property. This next topic here. Square root property says if you got something squared equal to something else, then you drop your squared and you put a plus or minus square root around the other side. For example, if I have x squared is equal to 25. Now we have the entire left side squared equal to something else. So our square root property says you drop your squared and you put a plus or minus square root around the other side. Now 25 is 5 times 5. And remember, the square roots, we're looking for a pair of something. So here's a pair of 5s, so they're going to come out in front as a single 5. So we got x is equal to plus or minus 5. And that's our answer. Now if I have x minus 1 squared is equal to 4. Well, the form still applies. We got something squared equal to something else. We'll drop our squared, and we'll put a plus or minus square root around the other side. And 4 is 2 times 2, so that'd be square root of 4 gives me 2. Now we're solving for x. We'll take negative 1 over. So we got x is equal to 1 plus or minus 2. Now whenever your radical disappears completely in these problems, then you can split this up. So we're going to have x is equal to 1 plus 2, and we'll have x is equal to 1 minus 2. So that gives us x equals 3, and x is equal to negative 1. And those would be our answers. Okay. Now if I have x minus 5 squared is equal to 24. Let's take a look at one more of these. Again, using the square root property, we'll drop our squared, and we'll put a plus or minus square root around the other side. Well, 24 we can simplify. That's 2, 4, 8 times 3. Now remember, we're looking for a pair of something, so here's a pair of 2's. So that's going to come out in front as a single 2. And we're left with a 2 times 3 inside, which leaves us with square root of x. Then we'll take the negative 5 and move it over. And we get 5 plus or minus 2 square root of 6. And that would be our answer. Sometimes on these you have i's appear. I remember is whenever you have a negative inside of a square root. Okay, let me clear that off. Grab a drink. Then we'll look at the next topic. Completing a square. Now for completing a square, our first step is to divide everything, all the terms, by the number in front of the x squared. I'm writing in terms of x's, but you can have any variable. Step 2, take the constant term to the right side. What's spelled wrong about that? I'm missing the S. Constant. There you go. Step 3, take the number before the x, multiply it by 1/2, square it, and then add to both sides. Then step 4, back to the left side. And step 5, use the square root property to solve for x. Okay, so let me make up an example. So we got x squared minus 6x plus 1 is equal to 0. Step 1. Divide everything by the number in front of this x squared. There is no number in front of x squared in this problem. Step 2. Take the constant term to the right side. So take this 1 and move it to the right side. You move anything across your equals, your sign changes. So the positive 1 becomes a negative 1. Step 3, take the number before x, which is negative 6, and you multiply it times a half and you square it. It's always times a half and it's always squared. Negative 6 times a half is negative 3 squared. Negative 3 squared gives us a positive 9. And then I say, then add it to both sides. So we're going to have x squared minus 6x plus 9 is equal to negative 1 plus 9. So we got x squared minus 6x plus 9 equals negative 1 plus 9 is 8. Step 4, factor the left side. This factors as x minus 3 squared is equal to 8. There's a little trick for that. Whatever number's right here, sign included, is always what goes right here. So there is no factoring involved at that point. Step 5. Use the square root property to solve for x. So we got something squared equal to something else. We'll drop our squared, and we'll put a plus or minus square root on the other side. Now 8 looks like something we can break down. 8 is 2 times 2 times 2. Remember, the square roots, we're looking for a pair of something. So here's a pair of 2, so they're going to come out in front. So we've got x minus 3 is equal to plus or minus 2 square root of 2. We're still trying to get x by itself, so I take negative 3 over, and we got x is equal to 3 plus or minus 2 square root of 2. And that would be our answer. Now, next topic is the quadratic formula. So let me clear this off. Then quadratic formula is when it's of the form ax squared, plus bx plus c equal to 0. Then your answer is going to be x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So if I have, for example, 3x squared minus 7x plus 5 equals 0. Now I want to solve this using the quadratic formula. Well, first off, we need to identify our a, b, and c. A is whatever's in front of your x squared, which is 3. B will be whatever's in front of your x, which is negative 7. And c will be your number at the end, which is 5. It's always best when you use a quadratic formula to go through and replace all of your variables with parentheses before you plug in your numbers, especially if you mess up on signs. This helps reduce the errors. Now b we said was negative 7, so everywhere I have a b I'll put in negative 7. A we said was 3, so everywhere I have an a I'll put in 3. And c we said was 5, so everywhere I have a c I'll put in a 5. Now here a negative negative gives us a positive 7, plus or minus square root of negative 7 squared, which is 49, minus 4 times 3, which is 12, times 5, which gives us 60. All over 6. See, 49 minus 60 is negative 11 over 6. Now remember, a negative inside of your square root gives you an I. So this is going to be 7 plus or minus I squared 11 over 6. Whenever you have an imaginary part, you split up your real part separate from the imaginary part. So put 7 over 6 plus or minus square root 11 over 6 with an I to the side. And that's our answer. Now I'm not going to go over the discriminant. If you watch the video I put out there, you'll see how to solve that. I want to make sure I have enough time to get through all the rest. Solve an equation for a specific variable. This is using all the same steps that we did up above, where we solve literal equations for a specified variable. So here the only difference is that you may have to use the square root property. Let me show a quick example. If I have a minus 2 squared is equal to bx. I'm solving that for a, for example. Well, a is trapped inside the parentheses here, so I can use the square root property though. It says if you got something squared equals something else, you drop your squared and you put a plus or minus square root on the other side. Then to get a by itself, we take negative 2 over. So we got a is equal to 2 plus or minus square root of bx. And that would be our answer. Grab a drink here. Okay. Now, applications of quadratic equations, I'm going to skip over that. It's possible I might have time to come back to it, but more than likely I wouldn't. And we'll go down to section 1.6. Hi, Tyler. I think by default you come in muted, and if you have a microphone and you want to unmute yourself, you just go up to that, you put your mouse on the top bar and it'll drop down, and you should see a mute and unmute option there. Now it also, you might be connecting your microphone at this point, so you might not have that option yet. And I'm just going through different material, and I'll go to 4:30. Yeah, 4:30, and then I'll shut off the recording for the YouTube video, and then answer any questions you have if you have any. Now, if you don't have a microphone, I think there's a chat feature. Maybe I'm wrong. I think I'm wrong. I don't see any chat feature up here. Okay. So section 1.6, polynomial equations. Now the polynomial equations, let me show an example. You'll have x to the third plus 3x squared minus 9x minus 27 equals 0. Let me double check that. Okay. This is an extension of the zero factor property. Zero factor property, remember, actually they call it the zero product property in this book, but it has different names. Says if you got something times something else equal to 0, then you set each factor equal to 0. Now we're extending this. Instead of potentially having just 2 items, we'll have maybe 3 factors. Well, again, the first thing you have to have is you have to have 0 on one side, which we do. And then we're going to factor the other side. And this factor is using grouping. The reason why I know it's grouping is because we've got 4 more terms. So I group first two terms together and group last two terms together. Now the first two terms have an x squared, so I factor out an x squared, and that gives us x plus 3. And the last grouping has a negative 9. Remember, if your first term is negative, you also bring out a negative. And that gives us x plus 3. Now our goal with grouping is to get this parentheses the same as this parentheses, which they are. So I'll factor out an x plus 3. Now to decide what goes in your second set of parentheses, you can go up to your previous step, cross out the x plus 3's, and what isn't crossed out is what goes right here, which would be x squared minus 9. Now we can factor this down further. Because x squared minus 9 is two terms of the minus trinket. That's difference of two squares. And I didn't mean for that to be the same, but oh well. So x squared minus 9 factors as x plus 3 times x minus 3. So now our zero product property, if you get 0 on one side and you factor the other side, you write as a product, then you can set each factor equal to 0. So I would set x plus 3 equal to 0. I would set x plus 3 equals 0. And I'd set x minus 3 equal to 0. And then solve each one of these. This gives me x equals negative 3. And this one would also give us x equals negative 3. And this gives us x is equal to positive 3. Since those repeat, our two answers are right here. Now the rational equations has not changed any. That's the same as the rational equations up above, but what you'll find is at this point where you're solving for x, you'll end up with a quadratic. And again, what tells you you're going to have a quadratic is you'll have an x squared. And then that tells you use a zero factor property or zero product property to solve it. So instead of having a linear equation, you'll have that. Now radical equations. Let's talk about those. Now a radical equation is easy to identify. It's an equation, it's got a radical. So solving radical equations. Now our first step is to get a radical by itself on one side of the equals. We'll talk more about what do I mean by that. I want to look at some examples. But do not create a fraction. These are challenging enough without putting fractions in there. Step 2, raise both sides to a power equal to the index. Step 3, if you have more radicals, go back to step 1. Step 4 is solve for x. And that's pretty vague. That's what we're doing initially. But it'll either be a linear equation at this point, and you use your 4-step method for linear equations, or it'll be a quadratic equation, and you use the zero factor property. And then step 5 is to check your answers. Now this one you have to fully check it. This process will give you the correct answers, but sometimes it gives you false answers. And you don't know that unless you actually check your answers on these. So let me clear this off, and I'll make up an example. So we've got square root of 3x minus 1 is equal to 2. Now if we go through our steps. Step 1 is get a radical by itself on one side of the equals, but do not create a fraction. Well, this radical is by itself on the left side. There's nothing in front of it, there's nothing after it, we just got square root of something. Step 2, raise both sides to a power equal to the index. Now your index, remember, is whatever number is in this slot right here. And if there is no number there, then it's by default 2. So for square roots, we're going to raise both sides to a power equal to the index. So we're going to square both sides. So we've got square root of 3x minus 1 squared is equal to 2 squared. Now whenever your index matches the power you're raising to, they cancel each other away, and you're left with what's inside the radical. So we're left with 3x minus 1. And 2 squared is 4. Step 3 says if you have more radicals, go back to step number 1. We don't have any more radicals. Then step 4, solve for x. And this is a linear equation. So we're going to use our 4-step method. Well, our first step is get rid of parentheses, don't have any. Second step is get rid of fractions, don't have any. Third step, get everything with an x on one side, numbers on the other side. So I'll take -1 over. Remember, when you take anything across your equals, your sign changes, so -1 becomes a +1. 4 plus 1 is 5. And then we want to divide both sides by the number in front of your x. So we'll divide both sides by 3. And we end up with x is equal to 5/3. Maybe. Because remember, step 5 says we have to check our answers. So what we do to check our answers, we plug 5/3 back in for x. So we'll have the square root of 3 times 5/3 minus 1 equals 2. Now that's not really an equals at this point. This is a question mark. We're wondering if that's equal. Well, these 3's cancel, and I got 5 minus 1. We're wondering if that's equal to 2. 5 minus 1 is 4. And square root of 4 gives us 2. So we get 2 is equal to 2, so it checks. So x equals 5/3 would be our answer. Now I'm not going to work it, but if you had a different problem that looked like this, for example, and we have the radical by itself on the left side. The second step, where we raise both sides to a power equal to the index. Here we have a number in the slot, a 3, which means we'd take both sides to the third power. So when we do that, whenever your index matches a power, they cancel each other away. So I give us 5x minus 2 is equal to 2 to the third is 8. And then you would solve it down from there. Now, I don't know if I have, let's see if I can find a little bit more complex example. Section 1.6. This is out of another book. Let's take a look at this one. I want to find one that gives a quadratic after I take both sides to a power. And those I can't make up out of my head, so. Yeah, this one should work. That one will give a quadratic. So let me clear this off. Then we got x minus the square root of negative 2x plus 7 is equal to 2. Okay, step 1. Get a radical by itself on one side of the equals. So I'm going to take this negative square root and take it to the right side. I'll take this 2 and move it to the left side. Remember, when you move anything across your equals, your sign changes, so the 2 becomes a negative 2. And this negative square root becomes a positive square root. And now the square root is by itself on one side. Step 2. Raise both sides to a power equal to the index. Well, this is another square root, so we're going to square both sides. So we got x minus 2 squared is equal to the square root of negative 2x plus 7 squared. Now over on the left side, x minus 2 squared I have to rewrite as x minus 2 times x minus 2. I cannot just square the x and square the 2 because of the minus in here. The minus messes that up. If everything is multiplication, then you can do that. Now over on the right side, remember when your index matches a power, they cancel each other. So that gives us negative 2x plus 7. Now if I FOIL these, x times x, first terms, plus x times negative 2, that's the outer terms. Negative 2 times x, that's the inner terms. And negative 2 times negative 2, that's the last terms. And the right side carries down. So we got x times x, which is x squared, x times negative 2, negative 2x. Negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. You always combine together like terms, even if the process doesn't say. Negative 2x is negative 4x plus 4 is equal to negative 2x plus 7. Now step 3, if you have more radicals, go back to step number 1. We don't have any more radicals, so I don't have to do that. Step 4, solve for x. Now this is a quadratic equation. Again, what tells us it's a quadratic equation is we've got an x squared. And that says use the zero factor property or zero product property. Now that requires us to have 0 on one side. So I'll take negative 2x, move it over. And I'll take the 7 and move it over. Remember, when you take anything across your equals, your sign changes. So the negative 2x becomes a positive 2x. The positive 7 becomes a negative 7. Negative 4x plus 2x is negative 2x. 4 minus 7 is negative 3. Now the zero factor property says you get 0 on one side and then you factor the other side. That factor is using the PSD method. And this factors as x minus 3 times x plus 1 equal to 0. Now zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So it said x minus 3 equal to 0, and I said x plus 1 equal to 0. And we get x equals 3, and x equals negative 1, maybe. Because remember, we have to check our answers. If I put 3 back up here, put 3 here, that's 3. I put 3 here, negative 2 times 3 is negative 6, plus 7 is 1. Square root of 1 is 1. So then we'd have 3 minus 1, which does give us 2. Now negative 1. If I put negative 1 here, that's negative 1. If I put negative 1 here, negative 2 times negative 1 is positive 2, plus 7 is 9. Square root of 9 is 3. So this would be negative 1 minus 3, which does not give us 2. This is an example of where you come up with an answer that does not work. That's why you have to check your answers when you're talking about the radical equations. So there it is. Okay, now that's the first part here, radical equations. Now equations with rational exponents. So let's talk about those. We'll clear this off. And let's take a look at x minus 2 to the 3/2 is equal to 8. And for here, I'm trying to get x by itself, and this is a rational exponent. Rational exponent means fractional power. And how we solve that is we raise both sides to the reciprocal of that power. Reciprocal means fraction flipped. So this is 3/2, so take both sides of the 2/3 power. Now when you do that, these 3's cancel, these 2's cancel, and I got x minus 2. Now this I want to simplify, and since we got a number to a fractional power, what we can do is we can take the number up on top, the numerator, put it on the outside of a set of parentheses. So this would be 8 to the 1/3 power raised to the 2nd power. We can take the 8 to the 1/3, put that in a radical form, so that would be the cube root of 8 to the 1st. If you remember working with radicals, whatever number's up on top, the 1 is what goes as our power. Whatever number's on the bottom, the denominator, is what goes as our index. So then we got the cube root of 8. I want to simplify that radical. And 8 is 2 times 2 times 2. Now our index is 3, which means we're looking for a set of 3 of something. Here's 3 2's, so 3 2's are going to come out in front as a single 2. Then the squared carries down. So then 2 squared is 4. And I'll take that negative 2 over to the right side. Remember, you take anything across or equals, your sign changes. And we get x is equal to 6. Now technically we would check this. Anytime you raise both sides to a power, you always have to check your answer. In the interest of time though, I won't check it. It checks when I plug it back in. Okay. Now let's take a look at a problem where let's say I had x to the 2/3 power is equal to 9. Well, I do the same item. I'd take both sides, raise them to power equal to the reciprocal. So this is 2/3, so I'd raise both sides to the 3/2 power. 2's cancel there, the 3's cancel, I got x. And if I take the 3 and put it on the outside of the set of parentheses, we'd have 9 to the 1/2 power raised to the 3rd power. And that's one of your properties, says you can do that. 9 to the 1/2, if I put that back in the radical form, would look like this. Whatever's in your denominator is your index, whatever's on top is your power, which is simply just the square root of 9. And square root of 9 is 3, so we got 3, the 3rd power carries down, and that gives us 27. Now we got some errors here, or not some, we got an error here. And I like to do both these examples to demonstrate difference. Now here, before we raise both sides to a power, the number up on top is odd. When you have an odd number up on top, that means that there's no plus or minus. But on our second example, we have an even number on top. If you have an even number up on top, then you need to put a plus or minus. Now what I'm talking about when put a plus or minus, when you raise both sides to a power, you have to put a plus or minus here. So then our answer is actually plus or minus 27. So again, the driver behind all of that is whatever number's up on top. Now this next topic, solve equations in quadratic form. Let me clear this off. Now I should mention, Tyler, if you have any questions as we're going through, feel free to ask the questions. Just because I'm recording doesn't mean you can't ask questions. The college wanted the direct instruction, the first part, to be recorded, and then the last 30 minutes for me to shut off the recording. So if you had any questions that you didn't want thrown out on YouTube for the world to hear, then you'd have that opportunity. Oh yeah, equations, quadratic, and form. This is solving using the U substitution. Equations, quadratic, in form. step 1. Let the middle part be equal to u, and the first part be equal to u squared. And that's pretty vague, but we'll talk more about that here in a minute. Second step is solve for u. Then step 3, plug u equals blank back in and solve for x. Probably one of the most vague processes there is in algebra. And let me make up a problem. Let's see. X to the fourth minus 9x squared plus 14 is equal to 0. And I'm going to solve this using the u substitution. Now what tells me I can use the u substitution is if you can take the middle part, excluding the number in front, the coefficient. So if I can take the middle part, which is x squared, raise it to the second power. Well, when I take x squared to the second power, that gives me x to the fourth. So when you raise it to the second power, if it gives you the first part here, that's when you can do the u substitution. Step 1. Let the middle part be equal to u and first part be equal to u squared. So I'm going to let the middle part here be u, excluding the number in front, the coefficient. Now let this first part be u squared. So this becomes u squared minus 9u plus 14 equal to 0. Now the idea behind this is that after you do your u substitution, it's now quadratic. And we can use one of the methods we looked at earlier. This one will factor. This factor is using the PSD. And factors as u minus 2 times u minus 7 equal to 0. Then zero factor property, or what the book calls zero product property. If you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set u minus 2 equal to 0 and u minus 7 equal to 0, which gives us u is equal to 2 and u is equal to 7. Now step 3 says plug u equals blank back in and solve for x. Now whatever you said u is equal to right up here is now what you're going to plug in for the u down here. Up here we said u is equal to x squared, so we'll plug x squared in for the u. And then we want to solve for x. Well, this is the square root property. Remember, the square root property is when you got something squared equal to something else. And square root property says you drop your squared and you put a plus or minus square root around the other side. Drop your squared, put a plus or minus square root around the other side. And those would be our answers. Now, the reason why I'm so vague here, the middle part and the first part, is because they do not have to be terms. They can be anything. For example, I could have this. X minus 9 square root of x plus 14. Now you might think, well, it's got a radical equation, so I go through and solve it using the steps I looked at earlier in this session. But they wouldn't work. This is actually a u substitution. If I take the middle part, which is square root of x, raise it to the second power. Well, remember when your index matches your power, they cancel each other, so that gives us x. That would give us our first part here. So this is still another u substitution. The middle part would be my u, first part would be my u squared. So then step 1, we rewrite that as u squared minus 9u plus 14 equal to 0. And that's what we got right over here. So I'm going to skip down to this. That would give us u is equal to 2 and u is equal to 7. And then our third step, plug u equals blank back in. In this problem, we said u is equal to square root of x. So we'd plug square root of x back in. And then at that point, you'd solve for x. So in this case, it's a radical equation. So I'd square both sides. and we'd end up with x is equal to 4. And here I'd square both sides. And we get x is equal to 49. We would have to check them, because again, when you raise both sides to a power, you get the correct answer, but sometimes you get false answers. Section 1.7, linear inequalities in one variable. So solving linear inequalities. Now we still have our note up at the top. That's true throughout algebra. Always combine together like terms, combine together numbers. First step, get rid of parentheses. And we do this via the distributive property, just like before. Step 2, get rid of fractions. And we multiply by the LCM of all the denominators. That's the same as before. Step 3 changes slightly. Get everything with an x on the left side, numbers on the right side. Step 4 is divide both sides by the number in front of the x. Note, if you multiply or divide both sides by a negative number, you flip the inequality symbol. I'll grab a drink here. As before, on step 3, I'm talking about terms. On step 4, I'm divide both sides by number in front of the x. Number in front of the x is a coefficient. So let me make up a problem. We got, let's see, 4 times x minus 1 plus 7 is less than 2 times x minus 3. Step 1. Get rid of parentheses. Now, I do have parentheses in this problem, so we're going to use the distributive property. We'll take the 4 times x and 4 times negative 1. And here we'll take the 2 times x and times the negative 3. So 4 times x is 4x. 4 times negative 1 is negative 4. 7 carries down. It's less than 2 times x is 2x. 2 times negative 3 is negative 6. Always combine numbers. Here we got negative 4 plus 7. So that gives us 4x plus 3. Step 2, get rid of fractions. We don't have any fractions. Step 3, get everything with an x on the left side, numbers on the right side. So I'm going to take this 2x and move it over to the left side, and I'll take this 3 and move it over to the right side. When you take anything across or equals, your sign changes, so the 2x becomes a negative 2x. The positive 3 becomes a negative 3. Always combine like terms in a step. 4x minus 2x is 2x. Always combine numbers. Negative 6, negative 3 is negative 9. Step 4. Divide both sides by the number in front of the x. Number in front of our x is a 2, so we're going to divide both sides by 2. And we get x is less than negative 9/2. And that's our answer. Now there are different ways that you'll see answers written. Let me talk about those a little bit. X is less than negative 9/2. That's just our form. We have something called set builder notation. Set builder notation means we put curly brackets, put the x with a vertical bar, and then whatever our form is. Now the curly brackets reads a set. So this says a set of all x values such that this is true. We have something called interval notation. Interval notation, if it's a less than, it's going to negative infinity. So we put our negative infinity first, and then negative 9/2. Now, infinities always have a parentheses on them, and the only time you put a bracket is when you got a line underneath your inequality symbol. This is a less than or equal to. Since there's no line underneath, that means that this is a parentheses. Now our graph. Parentheses on negative 9/2, parentheses on negative 9/2. And then you shade whichever way it's opening. It's open to the left, so I shade the left. And that'd be our graph. Now, let me talk about the other forms. If I work a problem down, and I come up with x is greater than or equal to 2, for example. Now that's our form. Our set builder notation, we'd put curly brackets, x with a vertical bar, and then whatever our form is. Set builder notation is the easy one. It's always curly brackets, x with a vertical bar, and then the answer. Now our interval notation, since it's a greater than, that means it's going to positive infinity. So that'd be 2, positive infinity. Infinities always have parentheses on them no matter what. Now notice on this one there's a line underneath. It's specifically x is greater than or equal to. Since there's a line underneath, that means that we put a bracket on a number. Now our graph, bracket on 2, bracket on 2. And then you shade whichever way it's opening. It's open to the right, so I shade to the right. And that'd be my graph. Now there's another type we'll look at. But let me write down the instructions for it first. We don't have time to really look at the union and intersection. Let's take a look at compound linear inequalities. Now I will put YouTube videos out that'll cover all these topics I've skipped, except for the word problems. I'm not very good at making up word problems out of my head, so you'll see there's very few YouTube lectures on that. But again, any problems you see in the book, you want to see worked, you just email me and I'll work them in a YouTube video and send you that video. Okay, compound linear inequalities. Solving three-sided compound inequalities. Step 1, get rid of parentheses. Step 2, get rid of fractions. Step 3, get everything, I'm talking about terms, get everything with an x in the middle, numbers on the other two sides. And step 4, divide all three sides by the number in front of the x. Now we have a note that goes along with this. It says if you multiply or divide all three sides by a negative number, then you flip the inequality symbols. Let me clear this off, and then I'll show an example. Okay, so if we have, let's see, negative 7 is less than 2x minus 1 is less than or equal to 5. Three-sided compound inequalities has three sides to it. It has the less thans and less than or equal to's. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Don't have any. Step 3, get everything with an x in the middle, numbers on the other two sides. So I'm going to take this negative 1 and I'm going to move it over to the right side and over to the left side. When you take anything across your inequality symbol, the sign changes. So the negative 1 becomes a positive 1. At any step, combine together like terms. Negative 7 plus 1 is negative 6. 5 plus 1 is 6. That's interesting. They both come up 6. Okay, step 4. Divide both sides by the number in front of your x. Or divide all three sides, sorry. Divide all three sides by the number in front of the x. So I'll divide everything by 2. So we end up with negative 3 is less than x is less than or equal to positive 3. Sometimes when you're trying to be random, you think you're being random, but you're not. And see how these both came up as 6? Okay, that's our form. Now our set builder notation, when we've got three sides, you put your curly brackets, x with a vertical bar, and then whatever your answer was. Now interval notation. X in the middle between two numbers means it's between those two numbers. So we put our smaller number, which is negative 3, comma our larger number. Now specifically, the negative 3 does not have a line underneath here, which means this is parentheses. The positive 3, on the other hand, has a line underneath. Line underneath means you put a bracket. And then graph. We have a parentheses on negative 3, parentheses on negative 3, bracket on the 3, bracket on the 3. And then we shade whichever way they're opening, and they're both opening inwards, so we shade inwards. And that's our answer. And no time for the applications of inequalities. So let's come down here to solving absolute value equations, section 1.8. And let me clear this off. We got a formula for absolute value equations. And it says, if you got the absolute value of something is equal to something else, then you drop the absolute value, and you set it equal to positive the other side, and you drop the absolute value and you set it equal to negative the other side. Now it really is as vague as what I just said. You can have anything in here, just as long as you have the absolute value of something is equal to something else. Now it has to fit this form. You cannot have anything in front of it or anything after it. You have to have the absolute value by itself on the left side. So let me just show a simple example first. Here we got the absolute value of something is equal to something else. So the absolute value is by itself, nothing in front of it, nothing after it. I want to identify the P and Q. P is whatever's inside your absolute value, and Q is your other side. And our formula says we're going to have P is equal to Q, and we'll have P is equal to negative Q. So everywhere I have a P, I'll plug in x minus 5, and everywhere I have a Q, I'll plug in 3. So we got x minus 5 is equal to 3, and x minus 5 is equal to negative 3. Now at this point, these would be linear equations, and we'll go through our 4-step method for that. In this case, there's not much left except for move the number over. So I'll move the negative 5 over, and it becomes a positive 5. So we got x is equal to 8. And here I'll take the negative 5 over, and it becomes a positive 5. And negative 3 plus 5 gives us 2. So those would be our two answers. Now I'm not going to finish this problem here, but I'll kind of start the setup. We got 3 times the absolute value of x plus 1 is equal to 6. Now we have to have the absolute value by itself on the left side, or whichever side. In this case, I'm going to divide both sides by 3. Now when I do that, these 3's cancel, and I'm left with the absolute value of x plus 1, and 6 divided by 3 is 2. At that point, the absolute value is by itself, so we could go through and use our formula. Now if you had a different problem, where you had the absolute value of x minus 5 minus 2, and I'll put a 7 here, and I'll put a 3 here. So the absolute value is still not by itself. First thing I want to do is move this number over. You always do your division as the last part of getting the component by itself. So that becomes 7 plus 2, which gives us 9. And then I divide both sides by 3. And we get the absolute value of x minus 5 is equal to 3, and then you could identify your p and q and do like you did on the first example. Now sometimes students will not get that absolute value by itself, but they'll just dive right into the problem. And they get the correct answer, and they think, well, he's incorrect. I got the correct answer. Sometimes you will, but not all the time. So it's always safest to get the absolute value by itself. Now the next topic, I'm running a little bit over 4:30, but I want to go ahead and cover these absolute value inequalities. Okay, so absolute value inequalities. We have two cases of this. We have case 1 where we got the absolute value of something is less than something else. We can rewrite it using this formula. Negative q is less than p is less than positive q. Our second case is where we got the absolute value of something is greater than something else. Then we can rewrite this as p is less than negative q, and then we have an or, and p is greater than positive q. So for example, if I have the absolute value of x minus 5 is less than 8, the inequality will tell you which case it is. Absolute value has to be on the left side. Since this is a less than, that means it matches case 1. So I'll identify the p and q. P is what's inside their absolute value, and q is the other side. And our formula is negative q is less than p is less than positive q. So everywhere I have a p, I'll plug in x minus 5, and everywhere I have a q, I'll plug in 8. So I got negative 8 is less than x minus 5 is less than positive 8. Now we want to solve for x. So I'm going to take that negative 5 over to the other two sides. So I got negative 8 plus 5 is less than x is less than 8 plus 5, which gives us negative 3 is less than x is less than 13. And that would be our answer. On the other hand, if I had one that looked like this, there's a greater than here. Specifically, it's a greater than or equal to, but I want to show how you'd handle that. If it has a line underneath, like a line underneath here, you just simply put line underneath each one of these. Now the absolute value is again by itself, so what's inside our absolute value is our p, and the other side is our q. And our formula says we're going to plug that into p is less than or equal to negative q. There's an or here, and p is greater than or equal to positive q. So everywhere I have a p, I'll plug in x plus 1. And everywhere I have a q, I'll plug in 10. And then we solve each one of these separately. So take the 1 over. We got x is less than or equal to negative 10 minus 1, or x is less than or equal to negative 11. Here, take the 1 over, and I got x is greater than or equal to 10 minus 1, or x is greater than or equal to, that should be a 1, 9. And that would be our answer. And that's the last of the topics. So I'm going to go ahead and stop the recorder here, and then I'll answer any questions.